Hello, my name is Mary Jo Fender, and this is Math for Middle School. Today we're going to go over how to compute the constant proportionality between quantities using values in a table. What you'll need today is paper and pencil to follow along. Okay, take a quick second and let's get ready to learn. Before we really talk about constant proportionality, we need to understand what is a proportional relationship. And two quantities are in a proportional relationship when the two quantities vary and yet have a constant ratio between them. So what we're going to be looking for today is that constant ratio. And that constant ratio is called our constant of proportionality. Our first example that we're going to use today is cooking. It's probably one that you're most familiar with, because we all double, triple, and sometimes quadruple a recipe. At my house, we always like to make oatmeal cookies, and they never seem to go far enough. So our original recipe calls for 2 cups of oats to 3 cups of flour. Because we always run out seemingly sooner than we really want, we're going to double the recipe. And when we say double, that gives us our constant ratio right there because we're doubling it. We're multiplying times 2. So if you'll notice, our 3 cups of flour, when we multiply times 2, is going to be 6 cups of flour. Our 2 cups of oats, when we multiply times that same ratio times 2, is going to be 4. So our doubled recipe needs 4 cups of oats and 6 cups of flour. Remember, our constant ratio is 2 because we doubled. Another example that you guys might be familiar with is when you play soccer. And I have a table demonstrating soccer goals to attempts. Now, you'll notice for every 1 soccer goal, they make 5 attempts. Now, when we're looking for a ratio, we're looking for the rate of change between our x value and our y value. And when you have a table and it's going vertically, x is always on the left, y is always on the right. Now, when we do that, we always want to say our y value to our x value. So we're going to look for shots to goals. Now our change in y from 5 to 10, that's a change of 5. 10 to 15, that's also a change of 5. On the goals, 1 to 2, that's a change of 1. From 2 to 3, that's a change of 1. So I'm pretty confident with our first 3 rows that our constant ratio is going to be 5 to 1. For every 5 attempts, we make 1 goal. So if we look at our 4th row of our table, it says we make 4 goals, but our attempts are left blank. How would we figure that out if we know 5 shots for every goal? So probably the easiest way you're going to do this is you're going to multiply that 4 times 5 to equal our shots attempted. Now we can go ahead and check this to make sure that our constant rate of change is the same. So the difference between 15 and 20 is 5, and our difference between 3 and 4 is 1. So we still have our constant ratio. Now you'll notice that our 5th row is left blank. We have our shots attempted, but we don't have our goals made. As in our 4th example, we multiplied times 5 to fill in our y value or our shots. We're going to reverse the process. So instead of multiplying times 5, we're going to divide by 5. So if I made 25 shots, that means I'm going to make 5 goals. Now I can go ahead and check by continuing to see my rate of change throughout my table. So the change between 20 and 25 is 5. The change between 4 and 5 is 1. So I know my missing information, I'll go ahead and circle it, that I filled in is accurate because I have my constant ratio. So let's talk about what is the constant of proportionality. Constant proportionality is the ratio that the two quantities share. So let's take a look at an example. So Charity can read 15 pages in her chapter book in 40 minutes. The table shows the number of pages she reads in 15, 30, and 45. We need to figure out what is our constant of proportionality, or what is the ratio that our two quantities share. So remember, we're going to look at our rate of change between our x value and our y value. And remember, the left side of the table is our x, the right side of our table is our y. Now, it really doesn't matter which vertical column you compare first, as long as they all have the same rate of change. So I'm going to go ahead and do my x value first. So the difference between 15 and 30 is 15. Our difference between 30 and 45 is also 15. Our difference between 40 and 80 is 40. And our difference between 80 and 120 is 40. So what is our ratio? So remember, it's always y to x. So our ratio is going to be 40 to 15. Now, can we simplify this? Absolutely. And we really need to take it down as far as we can go. Sometimes we can take it down to unit rate, or sometimes we can get it close. It all depends on what you're really looking for as your answer. Now, I know 40 and 15 can both be divided by 5. So 40 divided by 5 is 8, and 15 divided by 5 is 3. So what is our constant of proportionality? Our constant of proportionality is 8 to 3. Now, we also might want to write it as a fraction. And when we do write that as a fraction, we're going to put our y value on top as our numerator and our x value down below as our denominator. Now, these particular positions actually tell us something about our situation. Remember, our x value is the number of minutes, and our y value is the number of pages. So we can actually start putting labels on these. So I can say 8 minutes, and our 3 is going to be pages. So I can actually say Charity can read 8 pages in 3 minutes. So our constant of proportionality is 8/3, or 8 to 3. We have time for 2 more examples. So which situation is proportional? In this particular situation, we have hot air balloons and we have song downloads. We can use an equation, k equals y over x, or y divided by x, to figure out our ratio. Now remember, our vertical tables, our x value is on the left, our y value is on the right. So I'll go ahead and put those for both tables. Now we're going to use ordered pairs. And ordered pairs are going to be found on the same row as each other. And I've circled them for you. So let's go ahead and use our equation for constant proportionality and see what we find. So in the first ordered pair, 10 divided by 1, our constant of proportionality this time is going to be 10 first. I'm going to keep it in fraction form. I like improper fractions, so I don't have to keep flipping back and forth. So our next constant, a proportionality equation, is 15 seconds. 15 seconds, 2 is prime, so unless 2 can go into 15 evenly, we can't simplify. It doesn't, so that's as far as we can go. Our third ordered pair is 20 over 3, or 20 divided by 3. 3 is also prime, so unless we can divide 20 by 3 evenly, it's already simplified. We can't. And the same, let's do 25 divided by 4 over 4. Only factors of 4 are 2. 25 does not have 2 as a factor, so that is simplified as well. You'll notice that each of these constants or ratios are different. So this particular table is not proportional. So let's take a look at song downloads. We're going to go ahead and use our ordered pairs. Remember, they're on the same row, 1x, 1y. And let's go ahead and use our equation. So I'm going to say 12 over 4, 12 fourths. 12 can be divided by 4, so that's 3 over 1. Our second ordered pair is 24 eighths. Both 24 and 8 can be divided by 8. And again, that's 3 firsts, or 3 over 1. 36 twelfths. Both can be divided by 12, so again, that's 3 over 1. And then our final is 48 sixteenths. Both can be divided by 16, so that's 3 over 1. You'll notice that each of these constant proportionality is 3 over 1, or 3 firsts, or 3. So this particular table is going to be proportional. That concludes our lesson for today, so let's take a quick review before we end. So proportionality means two quantities share a common ratio. Constant proportionality is what that ratio is called. And we have an equation for constant proportionality, which is K is equal to Y over X. Thank you for joining me today, and remember to work on your proportions this week so you can continue to improve. It's been my pleasure having you in class today. I'm Mary Jo Fender, and I'll see you next week.